What is the formula for the velocity of the center of mass for two masses m1 and m2 with velocities v1 and v2? I want to explore a little bit how this might go. This is a formal example, so sometimes I just toggle the slide and we look at what it does, but it might be nice to kind of think about how this will go. Sometimes a slide also skips steps and is not always super easy to follow, so that's one reason to maybe discuss it a little bit before simply doing that. So anyway, there's the formula with all the vectors and everything else for the position of the center of mass of two objects in relation to their position vectors. If I'm interested in the formula for the velocity of the center of mass, right? So let me write over here velocity of center of mass. That would be equal to, you could argue, maybe change in center of mass divided by the amount of time in which that change occurs, right? Because velocity really is like kind of like change in position over change in time, right? Delta x over delta t. This is totally cheating what I'm doing here, but maybe it's okay. I don't know. But I'm going to say like, so really what we're thinking about doing with this is something like this. We're going to take the change of this thing here and divide that whole thing by delta t. And this is, I don't know, there's maybe more, like to really show what I'm going to say here with all the algebra is something I personally just don't want to do actually in the space that I have here. Maybe I could say if you want to, you can go and see how it might work. It might be a little bit, we explored this a little bit, I think, in an earlier example where we looked at, just change of like an mv in relation to like Newton's second law. We did kind of a similar maneuver of like, how do you apply like a delta to like a whole expression? You might be able to find an analogy between this and that. But I think what I'd like to argue is that since the masses are all going to stay the same, let's just distribute this delta to each of the x1s and the x2s, right? In other words, this would be equal to like m1. This is, I don't know. I feel like I'm abusing the algebra rules a little bit here, but it's actually not that abusive, perhaps, of algebra. It's maybe, again, being a little bit obscure about some of the steps one would have to do. But we're thinking about just two objects that would have like an x1 final and an x1 initial and an x2 final and x2 initial, and then we're talking about the change in this whole expression. So if you did that really legitimately, you could probably kind of slog through the algebra there. Anyways, we're still talking about that whole thing though, divided by delta t. And so I'm going to claim, again, without doing all the algebra though, that I think what you can do is you can kind of distribute this delta t onto the two x's. And I'm going to say if you want to do all the algebra for this, have fun. Maybe we'll look at the slide and it will give us some further insight. But I'm claiming that you can do something like this with it. And maybe wait a second for me to finish writing it, because I say that claim and I'm not done writing it. Oops, that's sometimes where I get in trouble. It's like, don't make a claim before you're done writing it, right? Otherwise it might not make sense. Okay, but here's the claim I'm making, and that really simply turns into the formula just m1, since delta x, delta t are each really velocities. That turns into this simple expression with the two velocities, which really, so maybe let's look at the examples. I think it'll be summarized in there, at least I hope it will be. There again is the summary right there. And it looks like, actually it looks like all it did was kind of the same stuff that I just did. It also skipped some of the same steps that I didn't want to do. But the thing to notice is that the formula for the velocity of the center of mass is basically almost the same formula as the center of mass itself. It's just instead of referencing the positions of the two objects, we're referencing the velocities of the two objects.